Hello, welcome to my lesson. As I have always been introducing myself, I'll continue in the same trend. My name is Sosale Mohana. I'm a teacher. I think I'm repeating like a parrot. Doesn't matter. I've taught maths for over 50 years, mainly A-level maths and further maths, and my strength is in pure maths and mechanics, no statistics. Or no D1 discrete maths rather. No. I have been recording and uploading lessons on various topics, and by now, of course, we are now into, I think, video number 74 or 75, I'm not too sure. And we started with differentiation, and I spent some time teaching you how to differentiate from first principles. I gave you the list of formulae, told you how you can download the formula. I hope you have printed it and kept it, because I can't write the formula, I'll be using them. And also I talked to you about how to apply the formula to questions. And in the 2 lessons ago, I think I did talk to you about the relationship between peeling an onion, an analogy rather, between peeling an onion and differentiating a function of a function. Today I want to go further and talk of stationary points. You see, for example, if I have a curve like this, at this point the tangent is parallel to x-axis, and at this point the tangent is parallel to x-axis. I have taught you tangents and normals. Oops. So I think I'll have to rewind and go back a bit and just give you some ideas on tangents and normals. Let's do that. Tangents and normals. Well, something which I keep repeating, is anytime we did a concept in trigonometry, single angles, we proved the formula, we proved the identities, then we did questions, then we did equations. Identities and equations. In differentiation, you do one type of differentiation, then you do tangent and normal, maximum, minimum. Then you do trig functions, tangents and normals, maximum, minimum. Exponential log functions, tangents and normals, minimum. And all these things, it's a part of, in other words, indirectly you keep revising the various concepts. Oh, sorry, you might be wondering why am I holding the phone in my watch. I told you I have to limit the lesson to about 20 minutes max. So I need to keep this so that I don't go beyond that, otherwise it will become boring and half of you will run away and you'll stop seeing my videos and my purpose is defeated. Okay? So, if I have a curve y equal to f of x, let's say I take a point P where x equal to a, that is the tangent. Y is equal to f of x. And a perpendicular to the tangent at the point of contact is called the normal to the curve. Normal is a perpendicular to the tangent at a point. Look, gradient, remember the very first definition of dy by dx. So dy by dx at x equal to a is gradient of curve, and from GCSE you know it is the gradient of tangent. Gradient of tangent, gradient of curve at x equal to a, gradient of tangent at x equal to a. Then the gradient of normal, remember we did coordinate geometry, where I did mention that if 2 lines are perpendicular, one is a negative reciprocal of the other, meaning, so minus 1 over dy by dx at x equal to a is the gradient of the normal. So in other words, to find the gradient of normal, find the gradient of tangent, and then do negative reciprocal of that. I'll take a couple of examples to show this. I can take a simple example. Find the equation of the normal to the curve y is equal to simple curve x cube minus x at the point x equal to 1. Simple question. To start with, you start with simple things. When you do parametric equations, same story. We'll see. So therefore, first find dy by dx. dy by dx is 3x squared minus 1. So at x equal to 1, gradient of tangent is 3 minus 1, which is 2. Therefore, gradient of normal is minus 1 over 2. Also, remember, a normal or a tangent is a line. To find the equation of a line, you need the gradient, you need the coordinates of at least one point. I know the gradient of the normal. I want to find what at x equal to 1, what is y? 0. So, the point is 1, 0. So, therefore, the normal is, please, sometimes they say, in the form y equal to mx plus c. In the form ax plus by equal to c. In the form ax plus by plus c equal to 0. Or show that this is the normal. In any of those cases, always do, it's easier to do y minus y1 equals m times x minus x1 instead of doing y equal to mx plus c, because the chances of error are reduced, as simple as that. So therefore, y minus y1 is gradient times x minus x1. Cross multiply. 2y equal to minus x plus 1. So 2y plus x minus 1 equal to 0 is the normal. Right? Of course, as I said, this will be in the handout. So don't, in fact, I don't have time. Tomorrow I have to sit and do a lot of handouts. Oops. The equation of the tangent. See, in a circle, a tangent will cut the curve in just, or will touch the curve in one point. But that's not always true. For example, you see, if I have a curve like this, if I draw a tangent here, it can cut the curve again at another point. It's in other words, at this point, the curve and the tangent touch each other. But the line or the tangent can go and cut the curve in some other point. It's possible depending upon the shape of the curve. So don't be under the impression in your GCSE tangent means it cuts only in one point, but not necessarily in curve. For example, find the equation of the tangent to the curve y equal to 2 minus 4x squared plus x cube at 1, 1. Oh, sorry, 1 minus 1. Okay. That's now part A. That's part A. Part B. Find the coordinates of the point where this tangent meets the curve again of the point, let's say, let me call it at A1 at B, point B, where part C says find the equation of I will write it as normal because I'm making up this question now, but in case it is impossible, I'll change it to a tangent. Normal to the curve at this point B. Okay, so let's start with part A. Straight away find, I don't have to find y because you've been given y. So what's dy by dx? Minus 8x plus 3x squared. At x equal to 1, dy by dx is equal to minus 8 plus 3. You know, the other problem which I always have, I've seen children in the exam writing like this, minus 8x plus x cube. And it is me as a teacher to figure out, oh no, he's not referring to the curve, he or she is referring to the gradient of the curve of dy by dx. But it's not my job. Please understand, it is for you to demonstrate to me or to your teachers or to the examiner that you know what you're talking about. To me, mathematically, you're solving simultaneous equations involving two curves, that's all. You are not finding a tangent. So for heaven's sake, if you're doing dy by dx, write dy by dx equal to, if you're doing integration, say integral y dx equal to. Explain yourself, please. Don't blindly, an equal sign seems to be a solution for everything you do and you expect us to figure out as teachers. Please don't write dy by dx equal to. At x equal to 1, minus 8 plus 3 is minus 5, which is gradient of tangent. So what the equation of tangent? Y minus y1 equals minus 5 times x minus x1. So y plus 1 is equal to minus 5x plus 5, y equal to minus 5x plus 6. Now you're wondering, sir, why didn't you write it as 5x plus y minus 6 equal to 0? Nothing wrong, perfectly alright. But I always keep in mind what you're going to do next. I need to find the point where this tangent meets the curve again. I need to solve simultaneous equations with this and that. This question is already y equal to. So if I write the tangent as y equal to, then I can equate the two easily. Otherwise, if I write y minus 5x plus 6, my plus 5x minus 6 equal to 0, again I have to make y the subject and then substitute. And by any chance, in a hurry, you might forget a negative sign. So be careful. So my advice would be, do it directly. So therefore, I'll rub this off. I need to find where the tangent y equal to minus 5x plus 6. Is it minus 5x plus 6? No. I think I've gone wrong somewhere. Y plus 1 is equal to minus 5 times x minus 1. Y plus 1 equal to minus 5x plus 5. Y equal to minus 5x plus 4, not plus 6. Please change that to plus 4. I realize that. So y equal to minus 5x plus 4 intersection y equal to x cubed minus 4x squared plus 2. So I can say x cubed minus 4x squared plus 2 equal to minus 5x plus 4, or x cubed minus 4x squared plus 5x minus 2 equal to 0. Thus, it should satisfy x equal to 1. 1 minus 4 is minus 3 and minus 2 is minus 5 plus 5 is 0. So you don't have to do, remember, to solve a cubic, you are supposed to do trial and error. Yeah? But to find one root. In this case, you don't, because that point is given. So you know x equal to 1 is a root. So therefore, I know x equal to 1 is a root. Then x minus 1 is a factor. You can do long division to get a quadratic and solve to find the other two roots. Yeah? I had taught you synthetic division. So I'm not going to do long division. You can do long division. I'll show both synthetic division and factorization. Okay? Long division, you're all experts. You can do it. So I want to do synthetic division. It is coefficient of x cube is 1. Coefficient of x squared is minus 4. Coefficient of x is 5. The constant term is minus 2. The root is 1. So put a 0. Add 1 and 0 is 1. 1 times 1 is 1. So you put 0 for the first one. Add whatever answer you get, multiply by the root, write it below the next number, add minus 4 plus 1, minus 3. Minus 3 times 1, minus 3. Add, I get 2. Multiply 2 times 1, 2. Add, you get 0. You must get 0, only then you are correct. Otherwise you are wrong. This was an x cube. I am dividing by an x. This was an x cube dividing by an x. So I am left with an x squared. So I get, let me do it here. Where do I do it? So I can rub this off. Leave it there. So it's x squared minus 3x plus 2 equal to 0, which is x minus 2 times x minus 1 equal to 0. There's a point I want, that's the reason why I did it this way. So therefore, you know the roots are x equal to 1, x equal to 1, x equal to 2. Because you already had x equal to 1, you got another x equal to 1. Now this is where you can use your ability to analyze. X equal to 1 is a tangent. So in other words, two of those values must be the same. So instead of dividing by x minus 1, you could have divided by x minus 1 whole squared to straight away get x equal to 2. Yeah, that's one way of doing it. But no need to do that. Of course, you can do it the way I showed you. Of course, you're going to do long division. But I want to show you which, to me, in other words, remember, let me do it somewhere here. What did I have? I had x cube minus 4x squared plus 5x minus 2. Remember, I need to get x minus 1. To get an x cube from x minus 1, I need to do x cube minus x squared, isn't it? Because if you multiply this by x squared, I get x cube minus x squared. So I'll straight away write this as x cube minus x squared. Okay? X cube minus 4x squared, I have written as x cube minus x squared. Look, if it's confusing, ignore it. Just do long division. But this, I find it, for people who are good in algebra, will find this easier. So out of minus 4x squared, I've taken a minus x squared. So I'm left with a minus 3x squared. Okay? To get minus 3x squared, what do I have to multiply that by? I have to multiply by minus 3x, right? What do I get? I have minus 3x squared plus 3x. Yeah? So I have done that. I have done that. That's a 5x. I've already got a 3x, so 2x minus 2. Now look at this. Between these two, can I remove x squared common factor? Between these two, can I remove minus plus 3x squared? Where did I go wrong? No, minus 3x squared. To get minus 3x squared, minus 3x becomes plus 3x, isn't it? Yeah. I put an extra minus 3x squared. Minus 3x, I get x minus 1. I remove a 2, x minus 1. So I get x minus 1 times x squared minus 3x plus 2, which is what you will get when you do long division. So you can do it that way as well. I had taught you this before. I thought I'll just go over it in case someone new has joined and wants to learn different techniques. Okay, right? So therefore, I now know at x equal to 2, what is y. You can put it in the curve or you can put it in the line. But easier to put in the line. What's the line? Y equal to minus plus. So minus 10 plus 4 which is 6. So therefore, point B is 2, 6. Find the coordinates of the point where the tangent meets the curve again. Now, I want to find the normal. See, somewhere in your working, you've done dy by dx equal to 3x squared minus 8x. Please don't do it again. You already got it. So, I've seen students again finding dy by dx equal to 1. No, straight away I can do it. So, at x equal to C, at x equal to 2, dy by dx equal to 3 times 2 squared minus 8 times 2. 3, 4, 2 squared is 4, 4 is 12, 12 minus 16 is minus 4. Therefore, gradient of normal is minus 1 over minus 4, which is a quarter. Yeah, 3x squared minus 8x. 2 squared is 4. Yeah, I got that. The curve. 2 squared is 4, 4 fours are 16, minus 6. Yeah, it's correct. 2 squared is 4, 4 fours are 16, 8 plus 2, 10. Isn't it a minus 6? Y is equal to minus 5x plus 4, so it's a minus 6. That is a minus 6. Alright, so that's correct. Anyway, these silly errors I do make with the minus and the plus. I now know the gradient of normal is a quarter. So normal at B is y minus y1 equal to gradient times x minus x1. 4y plus 24 equal to x minus 2 or 4y minus x plus 26 equals 0. That's the equation of the normal. Why I took this question was to show you the kind of question that can come up, how to solve Simultaneous equations, a curve and a line, going over synthetic division, a long division, trying to find gradient, finding equation of a line. Remember, that's why I didn't start calculus till I did algebra, till I did coordinate geometry, remainder theorem, factor theorem, division. You need everything before you start on calculus. Okay. So that's a short course on tangents and normals. So I will stop at that stage, take up in the next lesson. Of course, the handout will have everything. In the next lesson, I will talk of maximum and minimum. In fact, I should use the word local maximum and local minimum, because maximum of a curve y equal to x cubed minus 4x squared plus 1 could be infinity. So we're talking of a local maximum and a local minimum, but generally maximum minimum means a local or a definite maximum and a definite minimum. We're not going into infinite values. Okay. Thank you. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.